Okay. So we're solving a problem here where material decays, so this would be a radioactive material, and it decays from 340 grams to 10.625 grams in 50 days. What is the half-life? Now the assumption here is that you've not yet learned how to use logs to solve this, so I'm going to solve this the long way. In Ontario, Canada, that's a grade 11 problem. Okay, so to start out, we're going to set this up where we've got a final amount, and that's equal to an initial amount which has been repeatedly divided by 2. And the number of times it's been divided by 2 is the total time divided by the half-life. This exponent represents the number of times it's been divided by 2. So for example, if you had a half-life of 4 days and this was decaying for 20 days, you've been cut in half 5 times because there are 5 4-day periods in a 20-day stretch. That would turn the exponent into 5. That's how this works. Okay, now let's put in the numbers here from the problem. So our initial amount was 340. And that decays, that is, it decreases to 10.625. And that's happening in 50 days, so time is measured in days here. So our exponent is 50 divided by the unknown half-life. What we're going to do is try and figure out how many times we have to cut this in half to get that. And then once we know that, we can take our answer and I'll show you algebraically how to determine the half-life. So again, this is the initial amount, that's the final amount, this is the amount of time that's gone by, and that's the half-life. Okay, so there's a couple of ways we could do this. I could set this up by drawing it out. This is not how I'm going to solve it, but it's an alternative way to solve it. We could start at 340, and then we're repeatedly cutting it in half, repeatedly dividing that by 2. So 340 divided by 2 gives you 170. Divide that by 2, gives you 85. Cut that in half. That gives you 42.5. Divide that by 2. 21.25. And then divide that by 2. And that gives you 10.625. So yeah, we'll solve it this way. Now that seems very convenient. Now remember, if you are solving such a problem and have not learned how to use logs, you're only going to be given a problem where the numbers work out nice and evenly. That is, if you take the initial amount and repeatedly cut it in half, you're going to end up with the final amount. You're not going to end up skipping over it. You can learn how to do that using logs. So if we look closely, we have taken our 340 and we've divided it by 2, 1, 2, 3, 4, 5 times. So all of this will work out if we take our value of 340 and we cut it in half 5 times. That means that from the initial equation, 50 divided by the half-life is equal to 5. Careful rearranging of this equation, 5 half-lives is equal to 50, and if we divide both sides by 5, you can see that the half-life is 10. So to recap, if 340 grams decays to 10.625 grams in 50 days, and we're looking for the half-life, we write down the half-life equation where the initial amount is repeatedly cut in half to give us a final amount. The exponent is the total amount of time. Let me write that here. Total time divided by the half life. And if you think about that, you should be able to make sense of this in the fact that this exponent represents the number of times the initial amount was cut in half. So we put in our values from the word problem, the known 50 days, 340 initial grams, and then the 10.625 final amount. And then from looking at this and understanding exponents, we understand that this is repeatedly dividing by 2. So I did a chart here where I took 340 and repeatedly divided it by 2, and then counted the number of times I had to divide it by 2 to get 1026. That gave me the exponent, and I know the exponent is 50 divided by the half-life, so with a little bit of algebra we found the half-life to be 10. I'm going to redo this solution. Instead of drawing out a chart, I'm going to show you another way of doing this. You could end the video now, the problem has been solved. I'll just stay tuned if you want to see a second way. So the second